today we're going to look at situations that uses algebra to solve problems. So we're going to use algebra to solve word problems, and we're going to start with looking at money first, because a lot of times we use algebra when we're solving money problems. So let's take a look at this type of word problem. It says we have 10 times as many pennies as nickels, 5 more dimes than nickels, 2 fewer quarters than dimes, and twice as many silver dollars as quarters. And the question is, express the number of each coin in terms of the variable if there are n nickels. So what we want to do is every coin, the answer needs to be written in terms of n for nickels. So, for example, because there are 10 times as many pennies as nickels, pennies will be rewritten as 10n. And for the dimes, because there were 5 more dimes than nickels, dimes will be rewritten as n plus 5. For quarters, there were 3 more, so it's going to be n plus 3. And then for the silver dollar, we're going to have 2n plus 6. All right, so we're going to use the same information, but instead of expressing the coin in terms of n, we are going to express the term in terms of pennies. So there are going to be p pennies. So for nickels, because there were 10 times as many pennies as nickels, or 10 times as many as nickels as pennies, the number of pennies would be 0.1 penny. For dimes, it would be 0.1 penny, because that's what the nickels was, plus 5. For quarters, it was going to be 0.1 penny, because that's what the nickel was, plus 3. And then for silver dollar, remember it was 2n plus 6. So instead of n, though, we have 0.1p for n. And so 0.1p times 2 becomes 0.2p plus 6. All right, so we're going to use the same information, except for now we are going to express the coin in terms of dimes, d. So for pennies, we're going to have 10d minus 50. And then for nickels, it would be d minus 5, because d was n plus 5. And then for quarters, it would be d minus 2. And then for silver dollars, it would be 2d minus 4. All right, so same information, except for now we are going to express the number of the coin in terms of quarters. So for pennies, it would be 10 quarters minus 30. For nickels, it would be the number of quarters minus 3. For dimes, it would be the number of quarters plus 2. And then for the silver dollars, it would just be 2 times the number of quarters. All right, so let's go ahead and say what we can do to solve problems with equations in general, kind of like a game plan on what we can do anytime we're faced with a word problem. There are 4 steps to solving problems with equations. The first step is to represent an unknown quantity with a variable. So you need to identify your own unknown, and you need to label that unknown with a variable. The second step is you need to represent any other conditions that are in that problem in terms of the same variable. You only want to be working with one variable. Your third step is you need to identify 2 equal quantities, so set up an equation. And then step 4 is to solve that equation. So let's do an example. We're going to choose a variable and then write an equation that could be used to solve the problem. We don't actually need to solve this, we just need to kind of set up the problem. So Coach Mahoney ran 6 times as far as he swam, and he cycled 30 times as far as he swam. If he covered a total of 37 miles and the triathlon, how far did he swim? So remember, a triathlon is when you swim, you cycle, and you run. So the total distance that he did was 37 miles. So first, let's identify just one unknown. We're going to let x be the length of the swim. And the reason why we're choosing the length of the swim is because the running and the cycling are in terms of the swimming. So because of that, we're going to let x be the length of the swim. Because now we can say that running is 6x because the length of the run was 6 times the length of the swim. And that means we can rewrite the bicycle ride as 30x because the length of the bicycle ride was 30 times as far as he swam. So now that we have all of our pieces kind of labeled, we can identify that those lengths have to total up to 37. So we should have x plus 6x plus 30x equals 37. So from there, all we would have to do is we'd combine like terms and then solve for x. Let's go ahead and look at another example. So for this one, we have a soccer field that has a perimeter of 380 yards. So remember, perimeter is twice the length plus twice the width because you're adding all the sides together. So it has a length of 40 1/3 yards. Oh, I'm sorry, its length is 40 1/3 yards longer than its width, which makes sense. So your length should be longer than your width. So the question is, find the dimensions of the field. So our unknown is the width, right? And our length is 40 1/3 bigger than the width. So that's what our length is equal to. So now we have our width is equal to W, and our length is equal to W plus 40 1/3. So remember I said that perimeter is the same as 2 times the length plus 2 times the width. So we want to set up our equation. It would be 2W plus 2 times W plus 121 over 3. So that's 40 1/3 converted to an improper fraction. So now to solve this problem, we would distribute the 2, combine like terms, and then solve for W. All right, let's take a look at another example. So this one we're actually going to want to solve. This one, a carpenter is nailing a baseboard molding along a wall. The wall is 88 inches long. He has nailed in place a piece of molding that is 32 5/8 inches long. And the question is, what length of molding does he need to finish the job? So how much more does he need? So we're going to let M be the length of molding needed. And of course, the molding that's already nailed, that plus the molding needing should be the length of the baseboard, right? So if the molding needed, which is M, plus the molded nailed, which is 32 5/8, is supposed to equal to 88. So if we solve for M by subtracting 32 5/8 from both sides, we would get that the molding needed is 55 3/8. Which makes sense if we plug the answer back into our problem. 55 3/8 plus 32 5/8 is equal to 88. Okay, let's do one more example. We have the drama club performing on Friday and Saturday nights. Okay, so attendance at the Saturday night was 1 1/4 times the attendance on Friday. So more people attended on Saturday than they attended on Friday. So 1 1/4 times the attendance on Friday. So if there were 95 people on Saturday, what was the total attendance for both performances? So remember, our unknown is Friday's attendance, right? And it said that Saturday's attendance was 1 1/4 of Friday's attendance. So we know that that Saturday's attendance was 95. So that means 1.25 times Friday's attendance was equal to 95. So now we can solve for Friday's attendance. We divide both sides by 1.25 and we get 76. So now we know that Friday was 76 and Saturday was 95, which means total for the entire weekend would be 171 people. All right, go ahead and try some problems on your own.